Okay. So yeah, the final project. So let me just pull that up real quick. You can still hear me, right?
Yeah. And do you think we'll be able to get a hold of the other two group members this time?
Yeah, I think so.
Probably it's kind of important that they're kind of collaborate with us on this if they want to get a grade for it. Or
Yeah, for sure.
participate with us.
So let's do Saturday.
Yeah.
It's it's a draft, right? It's not like an actual final project type thing.
No, it's just the design. So we're going over the 5 steps. Design.
Let me see.
Design, collect data, describe the data, make an inference, and then take action. So those all those parts.
Oh yeah,
They're due different times.
right, right. So one thing we could do is have a text group going out. So maybe Thursday we can really dive into what we want to do. But I can't remember. You had an idea, didn't you? That you wanted?
Yeah, my idea was to collect the price of turkeys
Before
and see what they are before Thanksgiving, like maybe a few days before Thanksgiving, and then see what the price is a few days after Thanksgiving.
Let's do it.
And see if there's any change.
Yeah, we can do that. That's for sure.
But I mean, yeah, we could try and submit that.
How about one thing we could do? Let's text our group again, maybe even tonight or tomorrow, and go over what they think. Or maybe tonight we can have them all kind of read the instructions. We can all read the instructions, and then kind of come up with an idea of what we want to do. But we'll kind of suggest that turkey idea.
Yeah, definitely. We want to get a few different ideas, and see what the rest everyone else thinks.
For sure. All right, man. Anything else about that though we need to discuss?
No.
I don't mean to rush that.
Final project coming up, and yeah, we can start the quiz.
Sounds good, dog. All right.
Yeah, this lesson was a fun one.
Yeah, there's a lot of equations. That's for sure.
There is.
But I don't mind that because it's kind of easier with just equations than trying to figure things out. Anyway, while you're required to work together, okay. So question 3. In a pie chart, where are the sectors different sizes?
Why are the sectors different slices?
That's your question.
Let
me pull up our rating too.
I believe it's C.
C?
Yeah.
Sorry, I'm trying to jump back and forth between pages. See, each slice represents a category in the area of which slice represents the proportion of the total occupied by the category. Yeah, that sounds good to me. How are bar charts and Pareto charts related? Well, aren't Pareto charts and bar charts, aren't they? I was going to say categorical. I guess we mainly use categorical, right?
Yeah. And they'll show us
very similar.
Yeah. The only thing that's different with the Pareto chart is that it's organized, it's sorted from largest to smallest. Bar chart, it can have all sorts of different shapes.
So look like 1800. There we go. Is that what you're getting?
Yeah, I think it put C.
Yeah. Okay, this is where it gets fun. We conclude the what do they call that again? The P high?
P hat.
P hat is
Yep.
normally distributed if NP is greater than or less or equal to 10 and N. I hate looking at these things because they just trip me out. Hold on. Okay. Is P the true proportion of same proportional? Or the same proportional?
P, I believe, is the sample proportion, right?
Let me go back to the reading. I read it earlier today.
Okay.
From what I got from the reading, the P hat,
Yep.
that's the sample proportion. So is the P, when it says is P, are they talking about P in general or P with the hat?
That's a good question. It could be, let's see.
You know what I'm saying?
Is no distributed P proportion. P, I'm pretty sure P is regular P is the sample.
What did you say?
I'm pretty sure it's the sample.
Sample size is large. The sample proportion P hat will be approximately normal. Okay, that is nice. What was the?
What is the true proportion expect? So the true proportion, I think, is something different. The true proportion is kind of like in a coin toss. If you think about it,
Yeah, random, like a random variable, right?
no, the true proportion is going to be 50-50 for a coin toss, just because there's only two options. So in this case, we're using P as our random variable because it's a sample proportion. I mean, so I may flip a coin and find that only 40 times or 40% of the time I get heads. So if I was doing the study, I would use P as my proportion. Does that make sense?
I think so. I'll have to like reread that part again, but with sample proportion.
Yeah, so sample. That's what I'm gonna go with. I mean, that's what makes most sense to me.
Yeah. Okay. Okay. So N, the sample size, right? That's an easy one. Is that too easy?
N is N is the population. So yeah, the sample size.
Okay.
All right. P equals 1/4. What is the smallest N that satisfies the requirement? This is a good one. So there's those two conditions, right?
Hold on one second, man.
Yeah.
Sorry, go ahead.
With question number 7, we'll have to find the smallest number N that fulfills the condition. That fulfills both conditions of N times P is greater than or equal to 10, or N times 1 minus P is greater than or equal to 10.
Wait, I'm sorry, Daniel. Can you say that again? So we have to find the P. Say it all over again, if you wouldn't mind.
So, do you remember if we go back and look at question 5?
Right.
So look at just above question 5. It says we have to P is normally distributed if NP is greater than or equal to 10, or N times 1 minus P is greater than or equal to 10. So we have to find a number for N that satisfies both of these at least.
Right.
So if we're trying to solve for N for the first one, what we have to do is we have to divide 10 by P, which gives us 40. And that works because 40 times a quarter, which is 1 over 4, is 10.
Okay.
And the other equation will work because it's going to be 40 times 1 minus P, which is going to be 3/4, and 3/4 times 40 is going to be 30.
Right.
So the smallest N that we can use has to be 40.
That's crazy, man, how you got that.
All I did was just I looked at the equation above 5,
Right.
and so it's just like think what's an N value I could use that will satisfy this.
Right.
Yep.
You son of a gun, man. That was good.
All right.
All right. What is the mean of P hat? All right. Let's find this. I'm gonna use my phone's calculator.
That is just P, so 0.4. P hat is the proportion, and the mean is given to us just by P. That's kind of the definition of P, is the mean of P hat. Does that make sense?
Right. That was easy. Sounds good, man. Standard deviation of P hat. So to do that, do that same equation, but I get to use Excel for this. Don't tell me yet, because I'm gonna get this.
Okay. Yeah, let me know what you get.
Okay. Daniel?
Yep.
Are you there?
Yeah.
I got 0.1, but I got a round.
Okay.
Did I do that wrong?
I got 0.1. Yeah.
Nice. Don't scare me like that, man.
Dude, that's right. You got.
Well,
That's a good. That's
okay.
right.
Yeah, 0.1. I'm like, dang. Okay. Cool.
Oh, I was just finishing the equation. Sorry.
You're good. This next one, 0.3 then?
Okay. Yep. 0.1. Okay. All right. Question number 10. Brittany's batting average is 0.03. We want to determine the probability that she will get more than 35 hits over the next 100 at-bats. So N is 100, P is 0.3. So, okay. So what is P?
Wouldn't that just be the same thing as the previous questions, 0.30? Or is that different in this situation? No.
Let's see. The batting average, so P, the mean, is 0.03. But we want to find out what P hat is, which the value of P hat is actually, if you go back to the reading, if you're at the reading, look at section 2.1.1.
2.1.1. Yeah, that equation that's p hat equals x over n,
Yeah. So in this
where x is
question,
the. Go ahead.
no, you got it. Go for it.
So this is where x is the number of individual. It's with the characteristics, the same characteristics, right? Or the
Yeah.
wanted
First,
characteristics.
what's
So
what's our x?
35.
Yeah. X is 35 and n is 100.
So that's easy. P value is 3.5, 0.35.
Yep. Now, what is the standard deviation of p hat?
Well, let me tell you, sir.
Yeah, let's put it in. Let's see, 100. What'd you get, man?
I got 0.046.
Yep. Yeah, that's right. Nice.
All right. Let me know when you get the z-score, because I'm going to do that real quick. 0.46.
Okay, I got it. I just made like my own Excel sheet, and so when I put in the variables, I'll just calculate it automatically. Kind of nice.
Yeah, no kidding. Give me 1 sec. Did you get 2.400?
No, I didn't. I got 1.091.
Okay, give me a second. I tried something different, but I think I got that wrong. So you did 0.46 minus 0.35, right? Divided by square root.
Oh, wait. Can you say that again?
Yeah, so the equation is p hat minus p, right? Divided by square root of p times 1 minus p divided by n.
Yeah.
Okay,
So I got
go ahead.
so it's p hat minus 0.35 minus 0.3 over the standard deviation, right?
Right.
I got 1.091. Let's see, there's some funky.
Okay, I'm getting like 2 different answers. Try that again.
4, 6, 5. Do you want to see my equation?
Yeah, just give me 1 quick second. What? So you got? What'd you get?
I got that right there. Can you see?
Hold on, let me switch over to the camera. Say something so it pops up.
Oh yeah. So here's my z-score I got.
Okay.
There's my p hat. Here's p. My n, my standard deviation. And that's what I got.
Okay.
So just do this minus this.
And then what did it come out to be, you said?
What's my z-score?
Yeah.
It's right here. It's 1.091.
Perfect. Man, I can't get it on Excel. But you got, I get the concept of it. I think I'm just plugging it in wrong. So you got, what was it again?
1.091.
1.091. Perfect. Okay. The next question: if the true proportion of people who support a political candidate is P equals 0.52, and if N equals 2,000 people are
Did
surveyed.
you do 13?
Did I skip 13? Oh, I did skip 13. I'm sorry.
Oh, okay.
Sorry.
Okay, so. Oh no, it's all good. All right, so we just put in our z-score, right? I think 1.091. Do everything right? All right, did you
What'd you
get
get for that percentage?
the same thing as I did? I got like 0.1376, so 1.38. Did you get that?
Yes, sir.
Nice.
0.138, you said?
0.138.
Cool.
Okay, let's see. The true proportion of people who support a political candidate is 0.52, and N is 2,000. People are surveyed. We want to determine the probability that the results of the survey will suggest the candidate is losing the election, getting less than 50% of votes. Okay. All right. So we're going to do this, put this into Excel. Our p-value is 0.52, right?
Yeah.
0.52. Oops.
You guys send me that sheet.
Oh, yeah.
No, I'll have to look at it.
I can send you a copy. It's not too bad. It's not too hard. It's going to be 0.5, and it's 2,000. Oops. Okay. So we're getting less than 50% is losing the election. Okay. So getting less than. So we're doing a left-tailed. So what's the standard deviation? I got 0.011.
Sounds good, man. I was just watching your screen.
Okay. I mean, I could be getting this wrong, so I don't know.
Oh, yeah.
What z-score would you use? Negative 1.79.
1.719?
1.790. Negative, yeah.
Negative?
Yep. So that's my z-score for if the candidate will lose. Be very likely. Let's put it in here. So now we have to test the left because we want them to lose. This is a chance they'll get lower. So about 3-4%.
34?
No, sorry, 0.0367 is what I got. So I just round up. So
37?
0.037, yeah.
Boom.
So pretty small chance. Oh, that's the last one. Sweet. But yeah, I can show you how I did this. It's just I put in these two variables,
Right.
my n. So this is my this is setting up my standard deviation, which is just the inside, and then my standard deviation is just the square root of whatever that is. My z-score is just going to be that minus that divided by my standard deviation. And this is my test to see if my n is big enough. So if I have like 20.
Yeah, I like that sheet, dude. Send it my way.
Yeah, I'll send you a copy.
All right, man. Cool, bud.
All right, should we submit?
I already did, my man.
Nice. I don't
It
want to
looks like we just missed one.
Did we?
The true proportion one.
Oh, did we? Oh, man. Oh, we missed 11 too.
Did we? Where's 11?
Yeah.
What would you put for 11?
I put deviation 0.46.
That's what I put. And I got it right.
Did you get it right? Oh, did you put 0.460?
No, I put 0.046.
Oh, you put 0.046. Okay, I put 0.46.
Oh, there you go.
Yeah, that's off. Okay. Well, cool beans. I guess we will. I'll just go back and correct that next time.
Yeah, man. Let's. I'll post the thing.
Cool.
Well, we should start that group chat though.
Definitely. Should we just send an email out or should we just text?
Whichever works.
Okay.
All right, man. I'll see you later. Okay.
Yeah. No. Did you want to do the text or did you want me? Because I'm fine with whatever.
I don't care.
Okay.
All right, man.
I can go ahead and do it.
All right. You do that, and I'll post the video. How about that?
Okay. Sounds great.
All right. Yeah. See you, bud.
See ya. Bye.